Science. I thank the ITM SLS Baroda University management for organizing such wonderful international online lectures so that we will be able to know what's going on around the world, what are the new research areas, and everything else. Thank you, sir.
Professor,
Absolutely.
Professor, just
Yes,
one
sir.
thing is that this ITM University has also School of Pharmacy. Fine.
Hmm.
So there lot of work is going on in pharmaceutical means medical science and informatics. Apart
Hmm.
from that, in the CS department of ITM University, many faculties they have their interest on applied artificial intelligence. Okay,
Okay.
they means Madonna, Archana, Vagare, and all young faculties they are there. Okay, so what I
Interesting.
suggest that before you come to June, in June you are coming to my lab. So before
That's
that,
right.
as I told you, that please give some suggestions on how they can set up the neuroscience laboratory in their university. Okay.
Consider it done. Yeah, sure. Sure.
Good morning,
There's
sir.
one.
I have one question.
Yeah, go ahead, Ms. Archana, right? Go ahead. Yeah.
Good morning, sir. It was really informative session. As my interest is in neurosciences, I have one query regarding other than imaging data, what different data can be worked and what are the sources for these data, reliable sources for these data. And for imaging, as I have explored, we have deep neural network and supervised learnings. But what about other kinds of data and what algorithms can be used for working on these data?
Yeah. Thank you. A brilliant question. So with regards to the data source and reliability of the data sets that we're going to apply, first, it depends on the clinical setup that we're working on. Specifically, we're talking about neuroscience setup or neuromedicine, if you like. If we are pretty much certain about the precision and the aptitude of the data being clinically recorded at our clinics or setups, it's fine. We can use our own clinical data sets. By clinical data set, I mean, we can use the demography of the patients or healthy individuals. We can use their laboratory data for their blood chemistry. We can use we can use the whole genome sequencing and the array of the genetic data that we get from them.
Okay, thank you,
We
sir.
can also use, yeah, sure. We can also use the electrophysiological data like MEG or hemoencephalography, FNIRS, or QEEG, fMRI, and we can use the imaging data. These are the things that we can use as original databases in our setups, but sometimes we do not have the access to original data sets, so we need to go to open source platforms that we can extract some data. So data is there, but the important thing is that how you're going to work on a data and what is your hypothesis, what exactly you're going to tap into, what is your question of research. So the data itself, ma'am, the data itself is not a problem. The problem is between our ears. The problem is how we're going to formulate and how we're going to approach the research project and research question. So you got access to everything, and either clinical or open access data, you can use it. But let's rethink how and why we're going to optimize the usage of the data and what value our research would be adding to prediction, prevention, treatment, personalized approach in medicine, and participation of the patient physician in the course of diagnosis and treatment. Good luck with that.
Thank you.
Professor, with your permission, I will share the Parkinson data set with Archana ma'am and Madonna ma'am. So let them work on that. It's a very good data set, and I'll give them instruction on how to proceed. Okay.
So, we are not only research partners, we're not only, like co-workers and colleagues,
Yeah.
and also adjunct researchers. We're
Yeah.
like close friends. We're brothers. You have all the privilege to do whatever you want to do that.
Yes. And later I'll share you the email ID of Professor Ujjal Dwivedi, and another research oriented person is there, Dr. Niraj Mehta. Okay, so they are all doctors. Means I'll send their email ID to you. You please
That'll be
contact
understanding.
them.
I'll be
Okay.
looking forward to that. Very
Yes.
good. Very good. So any
It's a nice
questions or
talk.
comments?
It's a very nice talk.
I'm very happy to hear that.
And
So is there
yeah,
any questions or comments from the audience here? If I could challenge you with my presentation, I would be really interested to get back challenged with your questions.
There is one question in the chat from a student. Can this be useful in BCI?
Well, the brain-computer interface and the brain-machine interface. So that's also another really interesting topic to tap into. And that goes hand in hand with robotics, with computer science and engineering, with spinning off new lines of startups and also research domains. Yes, because when we do the BCI got to be a neurofunctional model. So we need to detection the neuromarkers or specific features or components in electrophysiological data or EP data or imaging data, whatever. And based on that, we expect an outcome. It's all about the input, output, outcome. All right. So it's like IOO. And between the I and the first O, we might have hidden layers. We sometimes do not care what those hidden layers are, but we've got to be very cognizant and cautious that we have overcome the challenges of the error-prone, mechanisms, which is going to decrease the precision of our model. So first, the answer to your question is definitely yes. We are using AI machine learning in the concept of BCI and BMI, a brain-computer interface, brain-machine interface. And the base of the data is normally electrophysiological data, MEG or HEG data, or fMIRS data, or fMRI. And first, we need to stratify, classify, and manage the data, and then come to a predictive model, which is going to provide like a decision a tree or something. And when this feature is there, then the device is going to transfer item A into item B. So how come it would be possible to make it less error prone? By machine learning and by artificial intelligence. Hope that answers your question. Is there any questions or comments from the audience, or we're good?
I think there are no more questions.
Okay, great. So what I can say is that we definitely should be forward-looking to many things that will come into our commonplace for shared activities, for further research, and to provide something even at practical level for like startups, spinning off projects, and patents, or something which is going to enhance the quality of life of the people around us in the world, no matter where they are over the globe. We need to be there for humanity, for welfare and good of the people, for well-being, in one word. And when others are happy, we'll be happy. So let's make the world happier and happier and happier together. And we cannot do things like as a one-man show. It's a teamwork, and
yeah,
it's
absolutely.
a collaborative work. So let's do that. And I'm fortunate for this new chance of collaborating with our colleagues in Far East and India. I've been working with many teams, outstanding teams, but for me, you guys are also very, very, I consider working with you as an opportunity. I wouldn't take that for granted. I've been
It's a
working
very good
with my
lecture.
colleagues.
It's an
Thanks. I've been
outstanding
working with
lecture.
my, thanks
Yeah.
so much. I've been working with my colleagues in China, in US, in Brazil, in Netherlands, in Portugal, and also in Switzerland. I've been working with my colleagues in Panama as an adjunct faculty for the past 2 years.